Hello, and thanks for clicking on this next Knowledgeable One production. Today, we're going to talk about factoring greatest common factors. How do you factor a GCF? Okay, this is the first of our factoring series. We're going to learn all the different ways to factor, all the different methods, and we're going to see how it all works and how we can put it all together. So let's get started with factoring. Okay, so before we start anything about factoring polynomials, let's start with factoring the greatest common factor for just pairs of numbers that you've probably done since maybe the second or maybe the third or fourth grade or so. So if I ask you for the greatest common factor between 12 and 18, a factor is a number that divides evenly into another number. So if we list the factors of 12, all the numbers that multiply together to be 12, 1 and 12, 2 and 6, 3 and 4. If we list the factors of 18, we would have 1 and 18, 2 and 9, 3 and 6, and that's it. So now, what is the greatest common factor between the two? What's the largest number on both lists? 6. So the GCF is 6. That's the largest number that divides evenly into 12 and 18. For number 2, if I want the greatest common factor between 100 and 50, I'm looking for the largest number that divides evenly into 150, and that number happens to be 50. 50 is the GCF. 50 goes into 100 twice, 50 goes into itself one time. So that's how we find a greatest common factor numerically. That's part of our process for finding the greatest common factor of a polynomial. So, just so that we understand, when you factor a polynomial, it's the process of reversing the distributive property. So, for example, if I gave you 5 times x plus 4, you could distribute. You learned that probably in 7th grade or so. You get 5x plus 20. Okay? So, that's if I distribute. Now, what I want you to do is I want you to start with the 5x plus 20 and give me an answer of 5 times x plus 4. I want you to undistribute this polynomial. Okay, I want you to factor out the common factors from the polynomial to be able to write your answer in factored form. We call that factored form. All right? That's what we're trying to accomplish here. Now, there's a reason for it. It shows up when we talk about solving quadratic equations. One of the ways we can solve a quadratic equation is by factoring it. Okay? Now, here's a note. When you're factoring, the leading coefficient cannot be negative. If it is, you must factor the negative out of the polynomial. Okay? So, for example, if I had negative 3x plus 15, this leading coefficient is a negative. Part of my GCF would have to be a negative. I'd have to put a negative in the GCF because it needs to be factored out. All right? Okay, so that's the idea behind this whole process. All right, so let's get started with talking about factoring GCFs. So let's find the greatest common factor for each set of terms. Let's talk about the first one here. We're going to do this with numbers first, then variables. So here's how it works. I have a 7 and I have a 14. The largest number that divides evenly into both is 7. So 7 is part of my GCF. Next, I'm going to look at the x variables. I have 3 powers of x in the first term, 5 powers of x in the second term. I can take the smaller of the two out. So the smaller is x to the third. I can take x to the third out. Now the reason for that is x to the third is x multiplied by itself 3 times. X to the fifth is x multiplied by itself 5 times. Both of these, x to the third and x to the fifth, contain 3 powers of x. That's where I get my GCF of x to the third. But the simple way to think about it is whichever the smaller one is, that's the one you can take out. And then finally, the y's, I have 1 power of y here. There's a 1 there on the exponent. You don't see it. and then 4 powers of y there. So they have in common 1 power of y. I'm going to take that 1 power of y out. And there's my GCF. It's all done. All right, let's try the second one. We have 18 and 7. So we're comparing the 18 and the 7. Looking for the largest number that divides evenly into both. That's 1. All right. And then we have 1 power of x there, 3 powers of x there. So I can put 1 power of x out. It's the smaller of the two. I have 5 powers of y, 4 powers of y. So I can put out y to the 4th. And then there's 2 powers of z. This one doesn't have any powers of z. So I can't put any powers of z in my GCF. So my GCF is 1x y to the 4th. Or I really don't even need the 1 because there's something else in the GCF. So I can just write x y to the 4th. In the third one, I'm asking you for the GCF between 15, 20, and 25. The largest number that divides evenly into all three is 5. We have 3 powers of x, 6 powers of x, 2 powers of x. So I can take out 2 powers of x, that's the smallest. Then we have 5 powers of y, 2 powers of y, no powers of y. So I can't put any powers of y out in my GCF. So that's my GCF. That's how you find a GCF. Now we're going to use the GCF that we find to undistribute or factor our polynomials. In letter A, we want to factor, okay? We want to undistribute. We have 6x squared plus 8x. Start with the numbers. The GCF between the 6 and the 8 is 2. Okay, and then we have 2 powers of x here, 1 power of x there, so I can put 1 power of x out. And now, to figure out what belongs in the parentheses, after you've taken the GCF out, you divide by the GCF. So 6 divided by 2 is 3. There's 2 powers of x. There were 2 powers of x in this term. You took one of them out, so one of them remains. And then in the second term, 8 divided by 2 is 4. There's 1 power of x, but you took it out. No powers of x remain. And this is the answer. This problem is done. It's been undistributed or factored. Okay? You can check to make sure you're right. Just take the 2x and distribute it to the 3x plus 4. You would get 6x squared plus 8x. That's what we started with. So all factoring does is changes the form of the polynomial. It doesn't change its value. It just changes the way it looks. Okay, it makes it look differently. All right, let's try letter B. We got a 5 and a 50. 5 versus 50. 5 is the number that goes into both. Largest number. And then I have 1 power of x in my first term, none in the second term. I can't take any powers of x out. So I need to divide each one of these by 5. 5 divided by 5 is 1. And then I still have that x there. Negative 50 divided by 5 is negative 10. I don't really need this 1 in the front. And this is it. I'm done. If I distribute the 5, sure enough, I get 5x minus 50. All right, let's try letter C. Same idea. I'm talking about the 12 and the 21. Looking for the largest number that goes into both. And that would be 3. I have 3 powers of x, x to the third, 2 powers of x. The smaller is x to the second, 2 powers of x. I could take out 2 powers of x. We're going to divide and see what remains. 12 divided by 3 is 4. X to the third over x to the second. So I have 3 powers of x up top, 2 on the bottom. Take the 2 away, 1 will be left. This is x, or x to the first. 21 divided by 3 is 7. 2 powers of x up top, 2 on the bottom. So I'm going to take them both away. Now there's none left. This is my answer. Now we try letter D. 4x to the second plus 8x plus 36. GCF. 4 between the 3. 4 goes into 4, 8, and 36. The first term has 2 powers of x. The second term has 1. The third term has none. So I can't take any powers of x out because the third term doesn't have any to take out. So my GCF is only 4. I'm going to divide all of these by 4. 4 over 4, that's 1. The x squared stays. 8 over 4 is 2. The x is still there. 36 over 4 is 9. And I don't need this 1. So there's my answer. I took out the 4. I factored the GCF as best I could. This is what I got. In letter E, 6x to the third minus 14x squared plus 10x. GCF. 2 goes into all three of these, 6, 14, and 10. First term has 3 powers of x, second 2, third 1. I can take out 1 power of x. And then I'm going to divide by 2x and see what's left. 6 divided by 2 is 3. 3 powers of x up top. I took 1 away. 2 will remain. Negative 14 over 2 is negative 7. 2 powers of x up top. I took 1 away. 1 is left. 10 over 2 is 5. There's 1 power up top, 1 on the bottom. I took it away. This is my answer. Okay, we'll try a few more. Letter F. I'm looking for the GCF between 2, 20, and 6. That's 2. 4 powers of x here, 2 here, 1 here. I can take 1 power of x and put it out. That's the smallest of the 3. I'm going to divide all these by 2x. 2 divided by 2 is 1. 4 powers of x up top, 1 on the bottom. 3 will remain. 20 over 2 is 10. 2 powers of x up top, 1 on the bottom. 1 will remain. Negative 6 over 2 is negative 3. 1 power of x up top, 1 on the bottom. None are left. There's my answer. In letter G, 80, 50, and 30. Now, here's the first time we've seen it. There's a negative in the front. So I got to take the negative out as part of the GCF. So there's going to be a negative out there. 80, 50, and 30. 10 is the first number that goes, the biggest number that goes in all three. So my GCF now is a negative 10. 4 powers of x, 3 powers of x, 2 powers of x. I could take 2 powers and put them outside. So now I'm going to divide all these by negative 10x squared. Here we go. Negative 80 divided by negative 10 is 8. 4 powers of x over 2 powers of x. 2 are remaining. 50 over negative 10 is negative 5. 3 powers of x over 2 powers of x. 1 power is left. Negative 30 over negative 10 is positive 3. 2 powers on top, 2 on the bottom. They knock each other out. There's my answer. In H, 14, 21, and 7. 7 is the first number that goes into all three. I don't have to take a negative out. There's no negative in the front. That's all I care about. There can't be a negative in the front. Okay? Leading coefficient can't be negative. 5 powers of x, 2 powers of x, 1 power of x. Smallest is 1 power. I can take out 1 power of x. 14 over 7 is 2. 5 powers of x up top. 1 on the bottom, 4 are remaining. Negative 21 over 7 is negative 3. 2 powers of x up top, 1 on the bottom, 1 left. 7 over 7, that's 1. 1 power of x up top, none are 1 on the bottom. They knock each other out. There's none left, but I still need the 1 there. Now I have to have that 1 there. I can't take the 1 away, because if I don't have the 1, if I ever needed to distribute the 7x, I wouldn't know to distribute it 3 times to get back to where I started. Okay, so this 1 has to be there. All right, and finally, try one with more than one variable, but it's the same idea. Looking for the GCF between 3, 12, and 15. That's going to be a 3, but the leading term's a negative, so I'm going to take a negative out with it. 4 powers of x, 3 powers of x, 2 powers of x. I'm going to take 2, put them out. 5 powers of y, 2 powers of y, 1 power of y. So I'm going to take 1 power of y, put it out. And I'm going to divide by negative 3x squared y and see what remains. Here we go. Negative 3 divided by negative 3 is 1. 4 powers of x up top, 2 on the bottom, there'll be 2 remaining. 5 powers of y up top, 1 on the bottom, there'll be 4 left. Negative 12 over negative 3 is positive 4. 3 powers of x up top, 2 on the bottom, 1 remaining. 2 powers of y up top, 1 on the bottom, 1 remaining. 15 over negative 3, negative 5. 2 powers of x up top, 2 on the bottom. Now they knock each other out. There's no powers of x left. 1 power of y up top, 1 on the bottom. They knock each other out. There's no powers of y left. And this is my answer. And that's how you factor a GCF. As always, thanks for clicking.